Okay, so the next video that we're going to review is how do you solve exponential equations. I know these are exponential because x is the exponent. What our goal is what number would I plug in for this x to get the left side of the equation equal to the right side of the equation. The equal sign that they need to be the same and balanced. So what I noticed about the numbers 16, 4, and 2 is those are all powers of 2 in disguise. I know that 2 times 2 is 4, times another 2 would give me 8, and times another 2 would give me 16. So I could rewrite this 16 right here as 2 to the 4th power. I want to bring down the exponents because all I'm trying to do is show that 16 is the same thing as this. I'm not changing the meaning, I'm changing the form. I do the same thinking down here. So I know that 2 times 2 is 4, so I'm going to rewrite that 4 as 2 squared. So now let's stop and make some observations. I know that right here I'm going to use the distributive property because it's multiplication. So this is going to be the same thing as 2 to the 8x minus 12 over 2 to the negative 4x. I'm going to apply what I know about the rational functions unit. I can always undo division with multiplication. So I'm going to multiply this side by 2 to the negative 4x, but I'm also going to multiply this side by 2 to the negative 4x. Anything divided by itself is just 1, so this makes 1, and we're left with one group of, let me write it up here, one group of 2/8x minus 12 equals 2 to the 4th times 2 to the negative 4x. When we have the same base and we're multiplying, we can add the exponents. If you ever forget that rule, just go back to something that you know, like 2 to the 3rd times 2 squared. What that means is 2 times 2 times 2 times 2 times 2. So in other words, you're multiplying by itself 5 times, which is how you get 3 plus 2. So right here, since I have the same base, I can add these exponents. So altogether, my next step is going to be 2 to the 8x minus 12 equals 2 to the 4 minus 4x. So getting back to that idea from up here, we're trying to figure out when would the left side be equal to the right side? Well, if these are the same, that means these exponents have to be the same. 2 to the whatever this is has to match 2 to the whatever this is. So let's just take our exponents, 8x minus 12, and set it equal to each other. And now we do our old and familiar solving skills. If my goal is to get x by itself, I want to get them all to one side. So right here, these make 0, and it's gone from there, and this makes 12. I want to get the x by itself, so let's make another 0 here by adding 12 to both sides. 12x equals 16. I'm not going to get a whole number. That's okay. Let's scoot it back so that you can see. My last step to get x by itself is divide by 12. So x equals 16 twelfths, or 4 thirds. So that's an example of how you solve an exponential equation in the same base. Remember, the thinking is how can you rewrite each of the bases using the same one? And then once you get it down to one base equal to another, you think about what had to be the relationship with the exponents.